Hi everyone, this is an Olympiad question where quite a number of people don't even know that you can go about this in two ways. So we have 4 raised by the power of x minus 3 equals 108, and what is going to be the value of x? There are different methods of solving this. There are 2 methods of doing that, and the first one is just to start with indices. That is, we just going to start to be applying an index rule right quite from the beginning. And the second one is just to start with logarithm. That is, we're just going to start applying logarithm rule from the beginning. And it should be noted that at the end of the day, maybe the first or second method, we're going to have the same result. Therefore, I'm going to start with this first way, that is starting with indices. I write my solution. Then 4 raised by the power of x minus 3 equals to 108. So what am I going to do here is just to start to be applying index rule from the start of the question. And the first one I'm going to apply is the rule that says when I have a raised by the power of n and minus m, and this is going to be equal to a raised by the power of n, but this time around divided by the same a, which is the same base, raised by the power of n. And in the course of this right hand side here, I'm going to pick, that is the first one, the first variable. I'm going to repeat that, then divide by the same base, then carry the same power here, which is n. If someone looks closely, you're going to see that this format that I'm having here is just the same thing as what I have here in my question. What I need to do now is to write the right hand side of this expression here. Therefore, if I'm going to do that for my question, I have 4 raised by the power of x minus 3, and this is going to be equal to what? I'm going to follow the same thing as it is here. So I pick the first one, which is 4 raised by the power of x, then I introduce the division sign, and at the same time I'm going to write the same base, which is 4, exactly the way it is here, which is a. So I'm writing the same base at the same time, then here I raise it by the power of 3. Actually, that's what I'm going to write here. So I have 4 raised by the power of x, and this time around divided by 4 raised by the power of 3, now equals to 108. Obviously, I'm going to rewrite this left hand side. I can say 4 raised by the power of x, then over 4 raised by the power of 3 is just the same thing as 64 here, and this is going to be equal to 108, because 4 raised by the power of 3 and 64 are just the same thing. So what am I going to do is to remove this fraction so that I can have a straight kind of, and this is going to be easy for me to handle. Actually, everybody knows what I'm going to do in order to eliminate this 64 here, and I'm going to say that is multiply both sides by 64. That is, I'm going to say times 64 here, and at the same time I'm going to do it to the other side, because in mathematics, whatever you do to the left hand side, you just have to do it to the right hand side too. So I have multiplied by 64 here. Trust me, 64 is just going to go for 64 here. Then I have 108 multiplied by 64 here. Therefore, at the end of the day, I have 4 raised by the power of x equals to 108 times 64. At this point, I'm going to apply logarithm to both sides here, both left hand side and right hand side. So I'm going to have log of 4 raised by the power of x equals to log of 108 multiplied by 64. Just put this in brackets. Then if I apply logarithm to this left hand side here, what am I going to have? That is log of a raised by the power of n is just the same thing as n log of a. So if I do the same thing to this left hand side, what am I going to have? X log of 4 equals log of 108 multiplied by 64. Then at this point, I'm looking for the value of x, that is what I want. I need my x at this left hand side, so which means I'm going to eliminate log 4 from this side of my x so that I can know what value of x is going to be. So in order to do that, I'm going to divide both sides by log of x. So if I do that, I have log of 4 rather. I'm going to divide both sides by the log of 4, and if I do that to this side also, I have log of 4. Trust me, you know what's going to happen. This log of 4 is going to go for this. Then I'm going to have x equals to all of this, which is log of 108 times 64 by log of 4. According to the rule of logarithm, this log is going to affect 108 and 64. That is, log of a multiplied by b in parentheses, and this is just the same thing as log of a and plus log of b. Check it out, this format is exactly what I'm having here. So I'm going to write the right hand side of this my expression here, and if I do that carefully, I will have x equal to log of 108 plus log of 64 then over log of 4. If that is the case, then I'm going to have, that is, this log of 4 is going to be split under each of these value. That is to say, I have log of 108 over log 4 as it is, then I have plus here, then I have log 64 over log of 4. From this point, everyone knows that 64 is just going to be 4 raised by power of 3. That is to say, log of 64 is just the same thing as log of 4 raised by the power of 3, and at the same time it's going to be 3 log of 4. At this point, my x becomes x equals to log into 4 multiplied by 27 over log 4, then plus 3 log 4 over 4. Yeah, 108 is just the same thing as 4 times 27, because I just have to need to break down to reduce this my expression. So in order to do that, I need to cut them small, and in order to do that, I have to split this 108 into 4 times 27, and in order to reduce this also, that is why I got 3 log 4. So by so doing, I have a way of reducing my expression here. This is obvious, log 4 is just going to go for log 4. Therefore, I have 3 left here. Then I'm going to apply the same logarithm here. So I'm going to have log 4 plus log 27 as I did earlier on to log 108 and log 64. That is, log a times b is just equal to log a plus log b. So if I apply the same thing to log 4 times 27, so definitely I'm going to have log of 4 then plus log 27 log 27. Then if I apply that here carefully, I'm going to have x now equals to log 4 plus log 27 over log 4 plus 3, because what I have left here is just 3, and that is just the 3, and except that log rule is applied here, and I have exactly the way it is here. And obviously this is becoming reduced the way I want it, because if I split this log 4, I have already another log 4 here, so this is going to reduce more and more. That is, x equals to log 4 over log 4 then log 27 over the same thing log 4. So I have it there, then this plus 3 is still there, hasn't gone anywhere, so I have plus 3. Having some nice time there, I just split this and I have it exactly the way it is here. It is quietly obvious that this is going to go for this. Log 4 cancel log 4, and I have 1 standing here. For log 4 goes in log 4, I have 1 standing here. Therefore, from this level, I have x equals to 1, because I have 1 here, then log 27 is still there over log 4, then the plus 3 is still there, which is here plus 3. If I add this 1 to this 3, I'm going to have 4 at the end of the day. X equals to 4 log 27 over log 4. I guess I can still do something to reduce this log 27 over log 4, and it's going to be this way. 27 is just the same thing as 3 raised by the power of 3, and 4 is just the same thing as 2 raised by the power of 2. Note that 27 is just 3 raised by the power of 3, and 4 is just 2 raised by the power of 2, which I'm going to insert here, having 4 plus log 3 raised by the power of 3 and log 2 raised by the power of 2. Then I'm bringing this power of 3 to the front here and this power of 2 to the front here according to the rule of logarithm. By so doing, I have x equals to 4 plus 3 log 3 then 2 log 2. I know I can still rewrite this log 3 over log 2. That is, if I have log a over log b, it can be rewritten and reduced as log of a then base b. So I'm going to apply the same thing here. What am I going to have? X equals to 4 plus 3 over 2 then log 3 base 2. Is this my final answer? Yes, that is my final answer, but I can rewrite this to give it a good look by saying 4 over 1 plus 3 log 3 base 2 over 2, which is just the same thing. Then I can bring this together closer so that I can have the whole thing in a one bunch. By doing this, I'm going to find the LCM, which is 2. 1 and 2 is the LCM. Then I'm going to say how many of these 2, that is this one, am I going to get inside this 2, so I can find 2. So what am I going to do with that 2? I multiply that with this 4, and this is going to give me 8. Then this plus is still there. Then say the same thing, this 2, how many of that am I going to get here, which is exactly 1. Everybody knows that. And what am I going to do with that 1? I'm just going to say the whole bunch here multiplied by the 1, and if I do that, I have exactly the same thing here, which is 3 log 3 base 2. And trust me, this is the final value for x. And remember how we started from the rule of indices before we arrive here, that is index rule, which is the first method. Now going to the second way, that is the second method, which is starting from the logarithm. Here is what we're going to do in this second method, is to apply the rule of logarithm from the beginning. That is, apply logarithm to the both side. That is, log 4 raised by the power of x minus 3 equals to log 108. Having this, x minus 3 is just going to come to the left hand side here according to the rule of logarithm, which says log of a raised by the power of n is just the same thing as n log of a, that is this power of n, move to this side. And exactly the same thing is going to happen to x minus 3, because that is just the power, that is the index. And doing this carefully, I have x minus 3 log of 4 equals to log 108. Then the next thing I'm going to do is to eliminate this log of 4, because what I'm looking for is the value of x. So I need my x to be at the right hand side, so I don't want the log of 4. So how am I going to achieve that? By dividing both sides by log of 4. Doing this carefully, actually log of 4 is going to go here 1, and it's going to go here 1. What I have left is just at this left hand side is x minus 3. Then I have the root of this at the right hand side, exactly this way. X minus 3 equals to log of 108 over log 4. In order to reduce this further, the best thing is to split this 108, and it is best split to be 4 times 27, because I have 4 at the level of the denominator. So that is the best thing for me, to split it into 4 multiplied by 27, which is exactly log 108 now becomes log of 4 multiplied by 27 in parentheses. And what am I going to do next to this is to carry out this index rule, which we've done before. Log a dot b, that is multiply, then it's going to be log of a, then plus log of b. So if I carry out the same thing here, I'm going to have log of 4 plus log of 27 at the end of the day. It is so fantastic that my log 108 has just become exactly this, which I'm going to replace with what I have here. Now my x minus 3 is now equal to log of 4 plus log 27 over log 4. The next thing I'm going to do is just to split this log of 4 then log of 27 according to the plus sign here. Log 4 over log 4 plus log 27 over log 4, in which it is very sure that this is just going to go for this. That is log 4 here, that is 1 log 4 here, that is 1. So the whole bunch of this is just 1. In that case, if I have just 1 here, what's going to happen to log 27 over log 4? I'm going to reduce that to exactly the same way by saying log of 27, which everybody knows that is the same thing as log 3 raised by the power of 3, log of 4, which is same thing as 2 raised by the power of 2. And if I do that, in order to reduce that, I have log of 3 raised by the power of 3 over log of 2 raised by the power of 2. And at the end of the day, this is just going to come down here, and this guy is going to come down here. And if that is done carefully, I have 3 log of 3 over 2 log of 2. And it is so wonderful that the whole bunch of this has just become this. If I replace this, I have x minus 3 equals to 3 log 3 over 2 log 2. Then what am I going to do next is to reduce this part as I did earlier on. And if I do, I have 3 log of 3 over 2 log of 2 now becomes, first of all, I have 3 over 2 into log of 3 over log of 2, in which I'm still going to reduce this. And if I do according to law of logarithm, so I have 3 over 2 and it's just log 3 base 2. If I insert this back, what am I supposed to have? I got this. X minus 3 equals to 1 plus 3 over 2 log 3 base 2. And don't forget, what I need, what I'm looking for is the value of x. So I don't need this minus 3 here. So I'm going to eliminate that so that I can know exactly what the value of my x is here. For me to achieve this, I'm going to add 3 to both sides. That is, I'm going to say to this left hand side plus 3 and to this right hand side plus 3 also. And for the left hand side, this plus 3 is going to cancel this minus 3. So I'm going to have 0 here. Then I still have my plus 3 here, having some nice time. Of course, if I do, what am I going to do now is this plus 3, I'm going to add it with this 1. And at the same time, I'm going to have 4 plus 3 over 2 log 3 over base 2. X is now equal to, that is 1 plus 3, that is just 4 here. Then this plus is still there, then 3 over 2 is still there, then I have log of what? 3 base 2. Is this the final answer for this second method? Yes, that is the final answer for this second method, except we need to write it in a bit fitting way as we did earlier on by saying 4 over 1 plus 3 log 3 base 2 over 2. So find the LCM, that's going to be 2, then this one, we're going to get inside this one, that's going to be 2, multiply that by this, we're going to have 8 here, then plus, then this 2, that is going to be gotten from this 2, and it's going to be 1. So multiply the whole bunch of this one by 1, and if we do that, we have exactly the same thing, that is 3 log of what? 3, then base 2. This is exactly what we got from the first method. That is x equal to 8 plus 3 log 3 over 2 log 3 base 2 over 2. This is from the first method, and it's exactly the same thing with the second method, which is this. And whichever method that you prefer, let me know from the comment section. I'm going to read that. This is second method, why the first one is just the first method. Just a moment before we go, we might need to verify if actually this value of x is correct or not, and we're going to do that. We're going to achieve this by inserting this value that we've gotten for x, 8 plus 3 log 3 base 2 over 2, into whatever we find x here. Then at the end of the day, we're going to see if this left hand side is just equal to this right hand side. And if it is actually is, it shows that this value for x is nothing but correct one. Now we're going to write this 4 raised by the power of x, but we're not going to write x, but we're going to write 8 plus 3 log 3 base 2 over 2, then minus 3. Exactly the way it is. Then is this going to be equal to 108 or not? Let's check it out. As we can see, the best way to subtract the bunch of this, that is 3 from the whole bunch of this, is to make this fraction also and say 3 over 1, because we have fraction here, so that we can easily find the LCM and do the subtraction. Let's quickly come down here and do the subtraction here and see what we're going to have. Of course, we have 8 plus 3 log 3 base 2 over 2 minus 3 over 1. Then the LCM is still going to be 2, exactly the way. Then I ask myself, how many of these 2 can I get here? That's going to be 1. Then what am I going to do with that 1? I'm going to multiply it with the whole bunch of this, that is multiplied by 1, and which is going to give me exactly the same thing here, which it is. Then I'm going to do the same thing here, ask and say, how many of this one can I get in this 2? Obviously it's going to be 2. Then what I'm going to do with that 2 is just to multiply it with the numerator, and 2 times 3 is just going to give me 6, but this minus, that is the minus sign, is still having some nice time. Then I have 6 here. Then at the end of the day, what am I going to have? So I can easily say 8 minus the 6. So I can relate that together. If I do that, I'm going to have 2 whole left here. So then I'm going to have 2 plus 3 log of 3 into base 2. Then the denominator 2 is still there, it hasn't gone anywhere, so I have over 2. Then I'm going to replace this with this power here. If I do that carefully, then I'm going to have 4 or 2 plus 3 log 3 base 2 over 2 equals to 108. Is it going to be equal to this 108 that is this left hand side? Is it just going to be equal to this right hand side? Let's watch that and see what's going to happen. Then the next thing I'm going to do to this left hand side is to rewrite this 4 in an index form. Don't forget the whole bunch of these are just together as they are. So if I do that, that is 2 raised by power of 2. It's just the same thing as 4 into brackets, that is 2 plus 3 log 3 base 2 over 2 is going to be equal to 108. Then the next thing I'm going to do, this can cut this in order to reduce that. So 2 go for 2 here. Therefore, what I have left is going to be 2 raised by the power of 2 plus 3 log 3 base 2, and 2 is gone, so that one is not, the denominator is not going to be there again. And is this going to be equal to 108? What we're going to do next is to apply this index rule, a raised by the power of n, then plus n. What this is going to be, or what does it mean, is that a raised by the power of n, then multiplied by the same a raised by the power of n. As we can see that this pattern is exactly the same thing as what I have here. Therefore, what I'm going to do is to write this right hand side of that. And if this is done carefully, I'm going to have 2 raised by the power of 2 multiplied by 2 raised by the power of 3 log 3 base 2. That's exactly the way it is here, and that is what is done here. And at the end of the day, here is going to become 4. That is what I'm going to have there, multiplied by 2 or raised by the power of 3 log 3 base 2. Having this 4 times 2 raised by the power of 3 log 3 base 2 probably is going to be equal to 108. The next thing we're going to do is to reduce this side also and see what we're going to have. To achieve that, this 3 is going to come into power here according to certain logarithm rule. And log a is just the same thing as log of a then raised by the power of n. So vice versa. The same thing here. This 3 is coming into the position of power of 3 here, exactly according to this rule, and that's what we're going to do. So doing that, we have 4 times 2 raised by the power of log 3 by the power of 3 into base 2, and exactly according to this rule. And what we're going to do next here is to multiply this 3 in 3 times. From this point, we're going to say 4 times 2 raised by the power of log. That's going to be 27 this time around base 2. So what are we going to do next? Having this, we're going to apply the second rule and say whenever we have a raised by the power of log of b base a, then the result is just going to be b. If we look at this critically, we can see similarity here. We have 2, then we have log 2 log into base 2, then we have a, then we have log into base a. So, and the result is just going to be whatever that is up here, which is b, and that is what's going to be whatever that is up here, and it's going to be 27. So what we say is that the whole bunch of this is just 27. That is, this go for this, so we have b left. So exactly the same thing. This is just going to go for this, and we're going to have 27 left. And don't forget, we just want to be sure if this is just going to be equal to 108. Is this just going to be equal to 108? Then at this point we say 4 multiplied by 27, and is this just going to be equal to 108? 4 multiplied by 27, that is 108, and it's just equal to the same thing as 108. And this has just shown that the value that we get for the value of x is just correct. So just before you go, keep on loving mathematics. Kindly like the video, make a comment, I'm going to read your comment, share, subscribe. I'm going to really appreciate that because it's going to help my channel grow. Thank you so much.